Welcome. This is a training video about how to use Git and GitHub together effectively. This has been delivered previously at the ICCS Summer School and in the context of the University of Kent Research Software Engineering Community of Practice. So what are Git and GitHub? Git is a version control system tool that helps you effectively manage the provenance, the history, the management of source code, of textual code, and its many versions and collaborations therein. And GitHub is an online platform that builds on top of that and provides a number of other features that we're going to see today that could be useful in the context of software engineering. So overall, what we want to avoid is problems like this, where you're working on some, textual document. Could be an essay, could be a paper, could be a piece of code, and you want to do different things, try different things out, and so you end up creating these kind of versions of it over and over and over again, and you have this complicated file structure, and you're not quite sure what's really the final version. Version control systems are about having an automated way of handling that so that you're not managing it yourself and not trying to come up with your own names for files. They automatically manage the versions of code for you and give you systems of managing those versions. We also want to avoid things like this, where you're sending around source code to your collaborators by zipping it up and emailing it over to them, and they unzip it and make some changes and send it backwards and forwards. That's a good way to get in a big mess where you have multiple copies of your source code with different changes, and you don't know whose changes you want to include and who's got the latest version, and it's difficult to merge together independent pieces of work. Tools like GitHub allow you to manage that kind of collaboration much more smoothly and automatically have multiple different what we call branches of work going on, different streams of work with different people, and then systems helping you merge those back together to have a single source of your code of your project. So these are the things we don't want to have. So these are open. Git's an open source tool, and GitHub is a part of Microsoft. GitHub used to be separate, and it was bought by Microsoft a couple of years ago. And there's a whole online platform. You can kind of think of it a little bit like a social network for code, because there is a kind of strong aspect of having this sort of open platform. Everyone can see. You can have public repositories that people can see, and you can follow developers and watch what they're doing and star their repositories and kind of follow along with what people are up to. You could also have private repositories as well for organizations where you're working on things that you don't want the world to see yet. So we're going to be going through some basics here. This is not a sort of a slow tutorial going through Git 101. I'm assuming that you've got a little bit of fluency already, and it's going to build on those skills and give you some core principles. So the plan is that at the end of the day, we'll see how we can use the Git paradigm for improving accountability in our projects and understanding the way it's been developed. We'll look at a few lesser known perhaps corners that you get into once you're in the early days, and we'll see GitHub's view of this and its organizational aspects. So the central way in which we organize things within Git is the notion of a repository. You can think of that as where your project lives, but within that we then manage what files are part of that and their changes and their versions. Now centrally with Git and the use of systems like GitHub, we have both a local view and a remote view. So the local repository might be what I have on my computer here, and the remote might be what I have on GitHub as this centralized backup store or place that we can coordinate work amongst multiple team members or amongst multiple systems. So we're going to link those things together so that changes from a local repository can be then reflected on the remote and vice versa. So typically we're in a situation where we have if we're in a collaborative situation, we have multiple local repositories. I have one on my computer, one on my collaborators' computers, and then we use the remote repository as a way of syncing up those changes. Or it might be that you're working in an individual context and you just have multiple machines. So I have my laptop here and my desktop machine in my office, and I want to sync up the changes between the two. It's also possible to have multiple remotes, but we're not going to be looking at that today. So let's go back to this view and link this up with GitHub, because that's going to be heavily tied into what we're looking at today. So I'm going to be using this repository that I have already on the Kent software organization here, and within repositories we've got a couple of things here. You can create a new one, and that sets a new one up. I'm going to use this one that's pre-existing, and I'm going to draw that down to my computer in just a moment. So I can do that by using this git clone command and then the address to this repository. And in GitHub, there's this handy little thing here. You can click on this. It gives you the URL that you can use to do that cloning operation. So I'm popping down in my terminal here, and I'm going to do git clone on that URL. And I've now got this folder called Git and GitHub material, which contains this file that's here, that we can see here in this file view, that's called exercise sheet. I'm just going to close this helper because we're not going to get into that today. But this is we can see that it contains files, and we've got those now locally on our local repository. We've created a local repository. Now there's another pathway that you could use, which I'm not going to demo, but roughly you could start by setting up a repository locally by creating a directory, going into that directory and running the command git init. And that will bring a local repository into life. It's not connected with any remote at the moment, but what you could do is then run this command, git remote add origin, and then the URL for your Git repository on GitHub, and that's going to link the two together and say, okay, the remote repository that I'm linked to is at this address. And from Git's perspective, we're naming that origin. So origin is the sort of the name for that remote repository in this context. So we're going to go on from here with our code that we've cloned, and we're going to do some changes and see how that works. So the local repository has this view that actually breaks into a few different kind of zones. So the working directory is the place where I have my repository centered on. I can create files in there, but files are not automatically part of the repository. The staging area is a place where I put changes that I want to consider to be included in the repository before they get finally what we call committed into the repository. This is also called the index in some documentation. So the working directory contains both tracked files, things that Git knows about, and untracked files, things that we don't know about yet. Once when I've got some files and I want them to be tracked, then I use the git add command, and it adds them to the staging area. And this is also true for any changes that I make. And then they become tracked. And then from there, I do something called a git commit, which then moves it into the repository, being part of the repository's history. So I'm just going to pop open this exercise sheet.tech file, okay, which is it's a LaTeX file that I was in the middle of converting at one point into a Markdown file. And so let's say I want to go and do some work on this. Just make that bigger. It's not particularly important what the details on here, but let's say I'm going to fix a few things up here that look a little bit wrong. Do a few more conversions over here. In fact, I might just remove this whole section here because that was from a different workshop. And so I've made some changes to the file. Now those changes are not automatically part of the history yet. If I run git status, I can see what's going on. It tells us some bits of details, and it says here that we've modified exercise-sheet.tech. I can also run git diff, and it gives me a diff, a nice colored diff output of what's been changed. So the red is what was there before, and the green is what is there now. If I press enter here, it's going to show me that those changes, and that's really nice if I want to review what I've done. So I'm going to add this by referring to that file, and now I'm going to do git commit, and as part of this I'm going to include what's called a commit message by using -m, and that's where I'm going to explain what I've done here. So clean up and make this valid Markdown, So that is now part of our history in our repository, the history of this file and the history of this project. Now we want this to go up to the remote, and I'm going to do this command called git push. Just before I do that, I'm going to do git log here, and that's going to show us the log of all of the changes that have gone on in this repository, both the ones that were remote and the ones that I've just made. So at the top here, we see there's this commit. This thing here is called a hash. It describes, it uniquely identifies the change, or at least roughly uniquely. This is derived from the content of the files, and it has a very, very low probability of being produced from any other set of changes. But these hashes are used as unique identifiers within Git. So this refers to that sort of chunk of work that I've done. It says who did it, what time, and it includes my message. And then below this is other changes that happened in this repository before. So I'm going to go ahead and do a git push. We see some sort of things go by about writing the objects, compressing the objects, and we haven't seen any errors, so that's a good sign. I'm going to pop over to the GitHub here, refresh this, and we can now see our commit message, clean up and make this valid markdown. That happened 1 minute ago. Can look at my log of commits, and we can see that at the top there, and this is other stuff that happened in the past. So that's really useful if you're working with your collaborators. They can see what you've done, they get an explanation of what you've done, and they can review it and pull those changes down to their local repository. So what we're building up here in this version history is a chain of commits. The one at the front is called the head. So as we do more and more commits, we're growing this, and we can refer to each of those commits by this hash. You also get a shortened version, which you'll see here on GitHub. This is a 7-digit version, which is also a reasonably good way of identifying it. It means you have to do less typing. There are various situations where sometimes you need to refer to a particular commit, so you can use that as your way of doing it. So the head is the one that's at the front, and these all reside in something called a branch. We're going to move on to making our own branches at the moment. By default, the branch that we're on is called main. That's the single branch that we have at the start of a repository. So just a little aside on the commit messages, we did this git commit -m, and we wrote a string in here. The general advice is to be descriptive but concise. You don't want to be too long. If you want to give extra details, you can, but if you do that on a new line, then that will go into the message that you can see in Git, the sort of extra details. But you want to give a sort of one sentence quick summary of what was changed. This is a lovely little comic from XKCD showing increasingly strange and decreasingly informationful commit messages. I think we've all done this at some point. Anyone who's used Git, you kind of write, often the classic one is, you write a commit that says something like, fix the bug, and then you realize you didn't actually fix the bug. No, really fix the bug. Fix, or change, and things like this. But that's not very descriptive or helpful to your collaborators. So try and be concise. It helps you to trace ideas back when you're looking through the history. If you need to go back and go back to a different point in time, helps you filter out things that are unrelated. If you want to change the commit before you push, then you can do git commit -- amend. That's very useful if you've written a commit message and then you think, no, come on, that's not very good, or I made a typo in it and I want to amend it before I do the push. Okay, so let's see another feature now. If we add something into the staging area, we can also take it out using git reset. So I'm going to go back to my file here and make some changes. So say I want to do some changes over here, maybe just some simple formatting things, and maybe I want to delete that title. Then I could add these based on the file name. And so now those are part of the staging area. If I look at the status, we can see that these are the changes that are going to be committed. Over here, they've been moved from the working directory into the staging, but I can also do git reset and that's going to move them out. They're now unstaged changes. So we can look at the status again, see those are modified. Now, just a little advanced tip while we're here. I'm going to show you another command, git add -p. This gives you a way of stepping through the changes a bit at a time and deciding which ones you do or don't want to be in a commit. So it's going to show me them in what are called hunks. Those are kind of pieces or chunks of changes. So maybe I want to say, yes, I'm going to include that one. Oh wait, I didn't do more changes. Let me add some more changes on here so it actually becomes interesting. So I'm just going to reset that to moment, move those back out of the staging area into the working directory, and going to add some things here. Change this to be appropriate for this training. So I'm going to git add -p, and we've got everything given to us here, but I can use S to split that up, split that hunk into smaller pieces. I'm going to go say yes on this piece and no on this piece. Now what I can do is commit this and say something here. Now if I look at the diff again, we can see I've still got these changes that I made later in the file. I'm going to go through those. Actually, I'm going to do all of these in a hunk and say I've just started with this with a single quote. Now I'm going to change that to a double quote so I can use the single quote here without having to escape it. Remove mention of stash, as that's not in this tutorial. Okay, so I'm going to push that up. We'll see those commits on the remote. So git add -p is really useful if you've been doing like a really long load of work. You've been sort of working for a few hours or something, and you change loads of files perhaps, and you want to then break that apart into meaningful commits into smaller pieces. Git add -p allows you to go through a bit at a time and group those together in some logical way that's then going to help yourself or your colleagues. While we're here, I'm also going to make a new file. So this tutorial is saying there's going to be a file that people can change. So I'm going to say git, I'll use the touch command to make that file, names and food.md, and I'm going to add that. Oops. Okay. You could also do something git reset head -1, which is going to reset you to the commit that's one behind the head. So it lets you basically unroll that previous commit. That's only going to work easily if you haven't pushed it yet. So that can be useful if you've made a commit but you actually want to go back. You're going to put all those changes back into the working directory unstaged, so you can go ahead and do some other changes. So we've got push. What about pull? How do we move things from the remote into the working directory? So I'm going to demo this by doing some changes on the GitHub interface. You can edit things online, which is useful. So I'm going to do some changes over here. I'm in read-only mode, so I'm going to click Edit File and make some changes. So I'm just going to do some simple things here and press Commit. And so on the GitHub interface, I get to put the commit message in as well. So now I have some changes on the remote. The head of the remote is a commit ahead of our local. If I look at the log down here, that's not automatically merged across. The last commit is the one that's called add blank demo file, which we can see as being the previous one here. So what I can do is a git pull that's going to bring those changes in. And so if I revert the file up here, it's already been reverted, that's good. Then we can see we've got those changes. Now, we can sometimes get into a slightly difficult situation when we've made some changes and someone else has made some changes, and so the remote and the local don't have the same they don't have the same suffix. They've got different commits at the end. So there's a way of dealing with that, which there are sort of a number of ways of dealing with that, which we'll see. So this git pull that we just used is actually a combination of two commands internally. It's doing something called a git fetch, which is moving all the changes down into the repository, and then a git merge, which is taking those changes and applying them to the working directory. So it's really doing two stages at once. Now this git merge has to deal with the fact that there might be conflicting changes, and that can sometimes lead to conflicts that we then have to resolve. So as an example of that, I'm going to make changes to the same line on both the local and the remote. So I'm going to change that one there and show you git add -u. Another thing as we're going by, that adds everything that's been updated. And over here on the remote, I'm also going to make a change which touches the same line, so they're going to be in conflict. We're going to see git branch in a moment, so that's just what I'm talking about on this PR. So now I'm going to do git pull again, and I get this warning, I get this kind of problem here, this fatal need to specify how to reconcile divergent branches. So it sees that there's this divergence here, that the history of the two repositories is kind of the same up to a point, and then it changes, it diverges. So it's giving us a number of options about how to configure our system to do this, to deal with this problem automatically. It's giving us two paths. It's saying we want this thing called a false rebase. It's turning off rebasing to do a merge, or putting on rebasing and a few other options. I'm going to just override that for the moment by doing that git fetch and git merge that the pull corresponds to, and we can see here that we've got a conflict. Now that's what we would expect. We edited the same line. Now the way that this is being represented in the file is with this kind of markdown syntax which explains the problem. So the head is showing what we had locally, starts here and is delimited by this double equals line. And then the next part here is what's available on the origin. You see we're on the origin main branch here. So we have to choose ourselves how to reconcile this conflict, and that's fine. If we were working on different parts of the file, then we wouldn't get this conflict and Git would merge them in automatically. But because we've edited the same line, it's now saying, well, I'm going to need you to deal with this. So in this case, what I'm going to do is actually kind of combine them and sort of edit it myself to come up with this fix. And now let's look at the status. We're in this position where we've got unmerged paths. We have to fix conflicts, and we've got this modified exercise sheet. So I'm going to call this reserve conflict and push that. So we now see in our commit history we've got three things going on. We had wording change, which was the local one. We had add example of Git branch, which was the remote one. And now we've got this reserve merge conflict, which kind of dealt with that problem. Now it's a bit annoying that we've had to end up with an additional commit to explain how this was resolved. There is a different way of solving this though, which avoids having that extra commit. It's called the rebasing approach. So we were in this situation where we had to do a merge commit, and the disadvantage of this is that it kind of muddies the history. You have these extra things sitting around. It then ends up misattributing changes because you see that maybe it was someone else who had to do this merge, and so my work that I did then gets replaced by something that someone else did. So if you're using the git blame tool, for example. So blame lets you see who did the work, and you go backwards through the history, and it's going to look like someone else did it rather than me. I'd have to step back another step to find out that it was actually me who did that work. So that can be confusing as well, just because it's adding extra noise into the commit history. So instead of this kind of fetch then merge path, we're going to use something called fetch then rebase. So what fetch then rebase does is, so we've got a local change here, and we did some stuff, and then we've got some changes on the remote as well, represented by this red, bunch of different changes. The blue is the common prefix of their history. What a rebase does is that it moves our local changes out of the way, brings the commits from the remote into the history, and then replays our commits on top. And any conflicts that exist, because there might be conflicts, we get to resolve them now as part of these commits and actually rewrite these commits to deal with those conflicts. So it sort of ends up making the history, we don't have to have a special commit for that merge, we can make it part of these commits ourselves and resolve it, and then have this unified view with red, green, green. So we can do git pull -- rebase to do that for us. That's the same as us doing a git fetch, git rebase. So I will show you an example of that now. And note the order of the commits in our chain, in our history, is not necessarily time dependent. It's not in time order. So this red might have actually happened after we started working on these greens. Okay, let's see an example of that. I'm going to do another one of these kind of these changes where we change two things. So let's go into here. One for the names and one. And what I'm going to do here is also, while I'm at it, make some changes in a different part to show how those don't get conflicted. So I'm going to make a change down there. And over here, I'm going to make some changes up here. But I also wanted to cause a conflict, which was I've forgotten which one it was now. Oh yes, it was this line about 2 suitable widths. So I'm also going to add a change there, which is just some wording changes. Okay, so I'm going to do git pull -- rebase. And we see that there's a conflict, okay? So we go back into our editor and we see that the conflict is on this line. Notice that those other lines we changed them in different places, but they weren't in conflict. So again, I'm going to do my thing of resolving them. In this case, I'm just going to pick one, like that. And some editors, this particular editor, whatever it is, Tech Shop that's popped up, doesn't give me some widgets for dealing with this, but Visual Studio Code, for example, gives you little buttons to say, choose the local commit or choose the remote commit, and it sort of automatically deletes the other bit for you. Now we're in a state at the moment where we're in this intermediate state where we haven't pulled down these changes. We're trying to resolve this problem at the moment. So we've made this change. I'm going to add it, and then we get to looking at the instructions here. We can do a rebase -- continue. That's saying we have solved the conflicts, we've added them, and we want to continue with the rebase now. We're essentially rewriting those previous commits to have dealt with that conflict. And I'm being popped into a little editor here to give a commit message, which I could have done by doing a -m, I think. So let me just quit for a second. Oh, sorry, I already did it, but you could do this as well. Write the message. So we have successfully rebased, and if I look at the log, we can see we had the adding more detail that came from the remote and some wording changes here, and that included our fix. So if I do git show, and this is when the hashes come into play, I've copy pasted this hash, then it shows me what changed in that particular commit. And we can see this change down here as well. We've stuck with the change, because we stuck with that particular change from the remote. We don't see that kind of resolution when we did git show on the other one. So let me show you that again. So that was the stuff that happened on the remote. Let's look at the head. Actually, I can do git show head. So the only change is that one that was made earlier in the file, and so we kind of removed our change that we made on that conflicting line down here on line 19. So great, we avoided having this clutter of an extra merge conflict in our a merge resolving commit in our system, and we can push that up now, and so everyone has their consistent view. Okay, so git pull -- rebase. So let's talk about branches. Branches give us a way of creating essentially like a copy of our repository, where we then might go, what we can then go and start changing things, but it allows us to jump back to the previous version of the code very easily. So if we look at git branch, it shows us the branches that currently exist. There's just main, but I can make a new one, and I'm going to do that in just a moment. Okay, we're going to create a new branch. Let's call it feature. I don't know, yeah, that's just the name I'm going to call it here. It's not very imaginative. You might want to have something a bit more descriptive. So that creates a copy of our history. We're not in it at the moment though. We're still on our main branch. If I do git branch again, we can see that feature exists, but it's the one with the star and the green text is the one that we're currently on. If we do git checkout, then we move ourselves into this new branch. So here I can do changes and then still jump back to the main and get back the previous version before I did the branch. So what I might want to do here is do some changes like this, and then I can always go and check out main again and get back to the commit called C here on the slide, and see that state of things. So this is really great if you want to try something out, you want to develop a new feature, but then you still want to be able to go back and run the version of things that worked. And this is how we typically organize ourselves when we're developing and people are adding new things onto the software. And then you can use merge to merge those back together. Git merge with the name of the branch from main then lets us merge in what was on feature. And yeah, that can also create these merge commits if there's changes in both that need reconciling, like this. So we've seen a bunch of commands so far. I think we've seen all of the ones that are listed here. Yep, we've seen every single one of those. Now that's just, in some sense, the tip of the iceberg. These are kind of a lot of common ones, but there are a whole load of other things that we haven't seen yet. And there's lots of material online about more advanced Git use. Now what I want to do in the last bit is to just link this in with GitHub and see some of the organizational features that are there and how we can use that to organize our software development process. So I'm going to pop back onto this GitHub repository here, and we're going to look at two things. We're going to look at issues and pull requests. So in issues, this is essentially a public place where we can log problems that we've noticed with the piece of software. And this can be really good for allowing your users to request help, or maybe they found a bug, or maybe they can't do something and they want some support, or maybe you yourself are doing something and found a problem. So I'm going to create an issue here and say the markdown document has the wrong extension. Okay, so usually you want to include some actual description of the problem and be descriptive as possible. This is a very simple example, so there's not a lot for me to say. A nice thing you get over here is that you can do various things like assign it to someone. So, okay, I'm the only person on this repository, so I'm just going to assign it to myself. And then you can label it based on what kind of thing it is. So it could be, in this case, it's a bug. You can have multiple labels. We could say it's also an enhancement. But it might not be any of these. It could just be a help wanted or a question or a request for documentation. So now we can see that in our issue board here. So this is a really great way of then tracking issues that you have in your code. So I'm going to deal with this on our feature branch. Let's just check that I'm there. Okay, I'm in there. I'm going to use the git move command, which is going to let me move a file like that. And that's nice and relatively straightforward. Okay, so I just made that commit. We can see it in the log, and I can show that, shows that we did that moving from there to there. And now I want to push that. So I'm going to do git push, and it gives me a kind of an error here, fatal error, basically just saying, look, I don't know where you want me to push it to on the origin. I don't know which branch it's going to go to. It gives me the hint here of what I need to do. So git push -- set upstream origin feature. So it's saying, okay, when I push this, it's going to go to a branch that's also called feature on the remote, on origin. Now, I don't need to do that again. If I do any more changes, I can just do git push. I don't have to have all this set upstream stuff. But the first time I push to a remote branch, I have to do that. Let me go back to the repo here, and we see this thing has popped up on GitHub that says do a compare and pull request. So what a pull request is you're requesting that someone on this repository pulls your changes into another branch. So in this case here, what it's describing at the top here is that we're going to we're requesting that these changes are pulled from the feature branch into the main branch. And I'm going to say that this fixes, and I'm going to say #1. GitHub does this nice thing where it's going to link together the issue and the PR. One thing you can do in GitHub is you can do a few different kinds of, two different kinds of pull requests. You can just make the pull request as is, or you can also make a draft pull request if it's sort of work in progress. And then a nice thing there to do is to list all of the tasks that need doing and sort of where you're at. So you can do this with a sort of checklist in Markdown. So I'm going to make this as a draft pull request. See, it has this little tag draft, and if I look up in the pull requests here, this is showing what we've just made. And if we go over to issues, what we're going to do is kind of link these two together by I'm going to edit this, sorry. You can edit this afterwards and say fixes issue 3. You can see how it's given me even that drop down, so I can look at it. And then if you go back to the issue now, you can see that it says that this was mentioned now. D Orchard mentioned this issue now in this pull request. So that's a nice way of linking the issues and the pull request together. The issue is almost like the request, and the pull is the response. Okay, so I did that bit of work already. Check. Now I want to check that the Markdown actually renders. So I didn't do that. I can look at the fast changes. I can view the file, and hey, that looks pretty good to me. So I'm also going to mark that as with a tick. I don't need to do any other changes there. And I'm going to now say that this is ready for review. So when it's ready for review, it moves from being a draft to being a bona fide pull request that's open. And then the general idea is that you have someone else on the project review it for you. Now, okay, if you're working on your own, well, that's just you, so you don't really need to do it. But you can, if you do have other people on the project, you can add them in here and request review from someone else. I can't request a review from myself here, but you can also put labels on these and do assignees and things like that as well. So I'm just going to assign myself. So when it's ready to go and you've reviewed it, that's probably really a topic for another training. We can then do the merge, and so that's going to merge that for us online. It's going to merge it on on GitHub. And so if I go to the top level now, we can see we've got this merge pull request commit that's brought down those changes into our main. Now, if you notice up here, this issue, it says there's no issues anymore. There aren't any more open issues. So GitHub has automatically closed that thing for us because we mentioned it in the description of the pull request. So that was automatically closed, and we have no more issues. Hooray! And now when we're over here, we could pull those changes into that branch. We can check out main, go back to our main branch. We didn't have to pull the changes into the feature branch. We can just pull onto main, and now we've got everything updated there. So lastly, if you're coming into another project that you want to contribute to, then what you should be looking to do is to use this thing up here called fork. That's what you use if you want to join a project, and maybe you're not like a member of that project, you're coming from the outside. But what forking does is create a copy of it that lives in your own, well, you can choose where it goes actually, so let's click it. So this is going to create a new fork. I'm going to do this in my personal GitHub profile here, create fork. And that's bringing down a copy of that into my personal organization there. But the key thing is that it's a linked copy. So I can then do changes here and make pull requests back to the original point of origin. So say I go here and I make a section for names and a section for food. What was it? It was like favorite food or something, wasn't it? Favorite foods without duplicates. Pizza's pretty good, right? And I'm going to make that, I'm just going to do that on my main here. Wouldn't necessarily recommend that, but I'm going to do that here. But what I'm going to do now is I'm going to make a pull request back onto the main project. So I'm going to go back over here to this one, and I'm going to go to pull requests, and I'm going to create a new pull request that's going from no, sorry, I need to do it over here. Pull request, new pull request that's going to go from my version, and I'm going to take it. Okay, it's set up for me here. So we can see on the right, this is where it's coming from. It's coming from the D Orchard, Git and GitHub materials, the main branch, and it's going to go into the Research Software Kent main branch here. So to create that pull request, put some description in here. And so say I'm an external collaborator, I could be, or someone who's new to the project entirely. I'm just contributing to this now. I've made this pull request. Someone can go and review it and then decide whether they want to include it or not, have some discussion and so on and so forth. In this case, I'm just going to merge it. So the critical thing is not to just clone someone's repo and sort of make a copy and sort of completely get separated out from it, but to use forking and then link back via pull requests. Now, if you do belong to an organization and you're already part of it, someone can add you with read and write privileges to that repository, so you don't need to go down the pathway, but the forking is useful when you're contributing to something that you're not already part of. So the key thing there is that forking maintains a single point of linked origin, even if it's forked to other accounts. And then you use the pull request to draw it back, and it gives a chance for review. Key thing is don't make a copy and then upload your copy to GitHub separately, because then that disconnects the two and it makes it very difficult to manage those changes. Fork if you actually anticipate contributing. Clone if you just want to get a copy of it and use that stuff, but you're not anticipating actually making changes to it if you're outside the organization. And yeah, do follow up on your intention with a PR that brings the changes back. And people like having new contributors to a code base. So we've done a live demo of issues. It's a good organizing principle. We can refer to our issues in our commit messages as well. If you use special words like fix or close or resolve with an issue name, then that will also automatically close that issue from that commit. So we've seen some key ideas in Git and GitHub today. We've gone through a bunch of commands very quickly. That's all sort of assuming you're also familiar with the command line and maybe tried Git a bit before. We've seen how to use this in concept with GitHub. We briefly saw the idea of pull requests and this idea of having forks, and just a little graphic here. The idea of forks is to kind of have a hub and a spoke model. You have a central repo that people then fork out from, make changes that then get pulled back. And we've seen the use of issues and pull requests. There's another feature that we haven't looked at today, which is the project board, which is a way of grouping together issues and pull requests and getting this kind of Kanban style thing. But that's a subject for another kind of training. And I'll leave you with this witty quote that will make more sense now that you've learned a bit of Git. It is easy to shoot your foot off with Git, but also easy to revert to a previous foot and merge it with your current leg. And with that, I wish you happy software engineering, and I hope that you will go on to apply this to do good research. Thanks.